Okay, let's start talking about linear and quadratic inequalities. This is section 1, bottom of the page. You'll find it. But I'm focusing on these two guys right here. So a linear inequality, you guys know if it's like 6x plus 4 less than 20. And I said, hey, I want to find out what the inequality solves to be. I would take away 4, la, la, la. And I'd get 6x is less than 16. And I would divide both sides by 6. And then I would reduce my fraction and say x is anything less than, and then it would be 8/3, which is a fine answer. 8/3 is a good number. But if you wanted to, you could say, I like mixed numbers better, so you could convert it and say 2 2/3. And if it's an inequality, this is a fine answer. That's a great statement. You pick any number that's less than 2 2/3, plug it in for x, and it should make a true statement. So, what's a nice easy number that's less than 2 2/3? How about 0? If I put 0 in there, 6 times nothing is nothing, plus 4 is 4. I would say 4 is less than 20. Now, I can pick any number that's smaller than 2 2/3. I could have picked 1 5/9 to plug in, but I don't want to torture myself. Why would I do that? So a linear inequality, same thing it was in Algebra 1. In fact, it's an Algebra 1 concept. But we spice it up a little bit by doing this. We say, hey, anything that is less than 2 2/3. This is the same exact answer, but this is in interval notation. So sometimes they want us to use interval notation for something like that. Okay, so inequality notation or interval notation. That's fine. Let's kill two birds with one stone, though. What if this said less than or equal to? Well, then all of my work would have said less than or equal to. And the only difference would have been down here, instead of a parenthesis, I would have put a bracket to indicate that it's included also as part of my solutions. So I'm not going to spend a ton of time doing a bunch of linear inequalities, but I do know that the one linear inequality that's on your packet looks something like this, like 2 less than or equal to 3x minus 6 less than, let's say, something like 8. So if I have a double-sided linear inequality, and what makes it linear? It's first power. So I would say, hey, I'm going to have to get the x by itself, so I'm going to add 6. But since it's double-sided, I'm supposed to add 6 to both sides. I'd end up with a statement of 8 is less than or equal to, now I have 3x in the middle, and over here I'd have 14. But I don't have x by itself yet. I would then divide. And if I divide one side, I'd divide both sides. Now, what do I have for a final statement here on this double-sided inequality? I have 8/3. Oh my gosh, that's the same as the last one. I'm just making these up. X, and then over here I got 14/3. Now, that's a great inequality statement. It totally is. It indicates all the numbers that would be between 8/3, and if it makes you more comfortable, you could convert it. Make it a mixed number, it doesn't matter. And then over here, same thing. If you wanted to, you could say, hey, that's the same thing as what, 4 2/3? And that's a great inequality statement. But if they ask you to express this in interval notation, instead of writing all this x between here and here, you could just simply say 2 2/3 is the tiniest number, comma, 4 2/3 is the biggest number. Since this has the potential to be equal to it, we use a bracket. And over here, we would use a parenthesis. because it does not have the potential to be equal to that. Now, hey, I want to know if I did it right. Well, pick any number that's between 2 2/3 and 4 2/3. I think the number 3 is a pretty good choice. 3 is a number between those two. So if I go back to my original statement that looked like this, I could plug in 3 and say 3 times 3 is 9. 9 minus 6 is 3. This grand total would be 3. Is 3 between 2 and 8? Sure it is. So you can check your answers by plugging something back in that's in your interval. So that's interval notation. So that'll get you through that problem. It totally will. But let's talk about the one that looks quadratic. There's this guy right here, right? Now, quadratic stuff has a pattern to it. It totally does. But the one thing about quadratic stuff, like x squared minus 5x less than or equal to 6. Let's do something like that. Quadratic stuff, you've got to get 0 on one side. So the easiest thing to do is not just always move the 6. No, that's not always the easiest thing to do. If the highest powered thing is negative, and now I'm going to tweak my example. If the highest powered thing is negative, you want it to be positive. Why? Because it will affect how your answer looks. Remember, I haven't mentioned this yet, but when you divide both sides of an inequality by a negative number, you have to change the direction of the symbol. To avoid that, to make your life easier, you should just, I'm going to add that over, then I'm going to add that over. If I move this over, it becomes positive. I move this over, it becomes positive. I already have the 6 on this side, right? So I moved everything to the right-hand side. That means that inequality symbol is right there now, and there's a 0. Now just let that sink in for a second, because most people do not like to read an inequality backwards. Most people do not enjoy that. They say, you know what? Could I rewrite this and say, how about that? X squared plus 5x plus 6 is greater than or equal to 0. Instead of reading it backwards, because we always read from the variable to the number, this might be more pleasing to your eye. It is to me, so I do it that way. But what am I trying to avoid? If the highest powered thing is negative, I want it to be positive to make my math easier. And then, guess what I'm going to do? I'm going to factor. You better believe it. And I go, wait a minute, it's x and x. It's got to end with a positive 6, so it could be 6 times 1 or 2 and 3. In this case, it's 2 and 3, because I'm going to put plus signs here. And you'll see there's 2x, there's 3x, there's 5x. I got it right. Let me erase my little swoopies. So here's how we do this one. When it's a quadratic inequality, we find what's called our critical values. Our critical value here is -2. Our critical value here is -3. And what I'm about to do is draw a number line. On my number line, I have 0 right here in the middle. Let's put -2 and -3 on the number line. So -2 lives right here. -3 lives right here. And then we do that, is it an open circle or colored in circle thing? Well, guess what? Since it has this, it's a colored in circle. Now, here's the dealio. We're about to do something called number line analysis. So I'm going to get a different color pen. See, when I have the number line broken up, this is one of my stopping points, so I have all the information less than that. I have all the information between that, and I have all the information that's greater than -2. So I have 1, 2, 3 regions that I broke my number line into. And what we're supposed to do is test the values. So I'm going to pick any number on the number line, any number I could that is smaller than -3. I like to work in multiples of 5. I always do. So I would pick like -5 would be on this side of the number line. So I'm going to go back and plug in -5. But you know what? The easiest place to do it is right here. If I put -5 in wherever I see x, I'd have -5 plus 2. Well, what's in my first set of parentheses? -3. -5 plus 3. What's in my second set of parentheses? Well, that's a -2. So this is like saying, well, if I plug in -5, this whole chunk becomes -3. This whole chunk becomes -2, and I'm doing a negative times a negative. Well, that's a positive. I don't care that it's 6. I really don't care. I'm trying to show you a shortcut. If you plug in -5, this whole chunk of junk becomes negative. This whole chunk of junk becomes negative. A negative times a negative is a positive, and guess what? Positive stuff is always greater than or equal to 0. So what do you say? You say all the information on this side, oh God, that's not what I wanted. Well, it'll work. All the information on the left of -3 is valid. It's good stuff. It's what I call okay. Now, between -3 and -2, let's pick an easy number like -1.5. Let's go back. I'm going to erase what I put here. Okay. Whoops, I erased too much. Let me put some of it back. And if this was a -1.5, well, -1.5 plus 2 would be a positive answer. I'm just going to say that. This would become positive. Oh, crap, I forgot to change colors. If I plug 1.5 in. Well, what about here? What if I put a -1.5 here? This would be a positive value also, this whole thing in here. So I would have a positive times a positive. Wait a minute. No, I'm sorry. That's not right. Wait a minute. Let me make sure I'm doing that. -1.5. That's positive. That's positive. Positive times positive. It's positive. So that guy right there, that's fine too. That stuff's okay. I'm right. It's all right. I just had a little brain fart. Then, guess what? I'm going to do it one more time for my next region. Let me get rid of some of this stuff. Too much stuff. I'm going to pick a number over here. So the easiest number that's in this area, in my third region, the easiest number to plug in would be 0. So I plug in 0, and I go 0 plus 2, that's 2. And then I go 0 plus 3, that's 3. Well, that's a positive times a positive again. This stuff's going to be greater than or equal to 0. It's all okay. So what happens? Everything that is to the left of that, including that, everything between it and that, and everything, what? No matter what number I pick on the number line, I get a true statement for this inequality. No matter what number I pick. Well, using inequality notation, there's no way to say every number works, so sometimes they will say all real numbers, or sometimes they will just say this using interval notation. My answer is any number between -infinity and infinity, meaning all real numbers, every number. Now, does that always work? No. You know what? If this symbol right here was switched to, if this symbol right here was going this way, none of my answers would work. Nothing would make this true. What? If nothing's true, then we give it the good old-fashioned null set, or this means there is no solution to this problem. Now, here's the thing. That doesn't always happen with a quadratic inequality. You will either have one of these 4 answers. Oh, I got to change that color. That's horrible. Sometimes you get all real numbers, which is this in interval notation. Sometimes you get a no solution situation. But The one that is on the AP Calc Summer Packet does not follow that pattern. The one on the AP Calc Summer Packet is like this. Let me just do one that's a little bit easier since everything's already on one side. And I'm going to do a less than 0. The first step is make sure 0 is on the other side. Second step, factor it up. And this guy factors to look like this, which gives me what's called critical values. There's a 7, there's a -2. I'm going to draw a number line. There's a 0 on my number line. -2 lives over here. Open circle, because there's no potential to be equal to it, so it's open circle. And then over here is 7, open circle. Once again, what do we find? Well, we find this with every quadratic inequality. You're going to get 3 regions here. And we got 1, we got 2, we got 3 regions. I'm going to pick any number I want that's in this zone. So anything less than -2. I already told you I like to work in multiples of 5. So I'm going to go back up, and I'm going to plug in. What if I put a -5 here and a -5 here? What if I did that? Well, the first set of parentheses, I'd get -12, which is a negative number. If I put a -5 in here, the second thing, I would get a negative number. A negative times a negative is a positive. Is positive information less than 0? No, it is not. So this stuff here is, we don't use it. Now, take a look between -2 and 7. I got my buddy 0, so I'm going to go back up here and I'm going to put a 0 where the yellow is. If I put a 0 for x, 0 take away 7 is negative. But 0 plus 2 is now positive. What is a negative times a positive? It's negative. And negative stuff is always less than 0. It totally is. So this time, boom, I say this stuff in the middle is okay. It's bueno. And then last but not least, let's take a number in this third region. I like multiples of 5, so I'm going to pick 10. 10 would be in this zone over here on the number line. So let's go back. Let's replace the yellow information with the number 10. 10 minus 7 is 3. Positive 3. 10 plus 2 is 12. Positive 12. A positive times a positive is positive. Positive stuff is never going to be less than 0. So this stuff over here is poopy. We don't use it. So this time in my quadratic inequality, I didn't get one of these weird answers where it could be all numbers in the world or no numbers in the world. This time I've got a range. I'm between -2 and positive 7. This is written in inequality notation form, but interval notation, I would do parenthesis, -2, comma, 7, parenthesis. This would be called interval notation. I don't know which notation you're going to be asked for, so you should know both of them. So anyway, how do I know if I really did this problem right? I can pick any number that's in this region, any number between -2 and 7, and plug it back in. So I could plug in 5, let's say. 5's a number. What the heck? If I wanted to plug in 5, 5 squared is 25. Minus 5 times 5, that's 25. Oh, those would cancel each other out. I'd be left with -14. -14 is truly less than 0. So I validated my answer. I just said, yep, I'm right. So what I am showing you is a technique called number line analysis. And I got to tell you, I don't want to make these videos too long. I'm not even assigning homework. I'm just trying to show you how to do it. So when you look at the problem on the packet, you can do it. So this is what I call inside information. It's between 2 points. I call that an INI. Guess what? Look at my original problem. My original problem is right here. Do you see that my inequality symbol is pointing inward toward the problem. It's pointing at the stuff. I call those innies. Guess what? I'm going to erase this part right here. Guess what would happen if it was going that way? I call those outies. They're pointing out from the problem. If you have everything on one side, 0 on the other, you're going to have an innie or an outie, or one of these special answers. But if it's an outie, guess what? This stuff would have been poopy, and this stuff here would have been okay, and this stuff here would have been okay. Well, how do I write that kind of statement? Well, it's a compound statement. You could say, well, x, anything that is less than -2, or anything that is greater than 7. That is a compound inequality statement. In interval notation, check it out. You know this already. In interval notation, we would write it this way. It kind of looks like when you're doing a domain question. Everything that is less than -2, but not including it, not a bracket, not including -2. So we use a parenthesis, unified with everything greater than 7. So right here, this would be in, once again, inequality notation. Over here, that's interval notation. That's what that is. But a quadratic inequality, you're going to see that your number line gets busted up into 3 spots. I'm going to give you a total heads up. Unless it's one of these weirdo situations up here, unless it's one of these weirdo jobbers, it's going to be an innie or an outie. An innie or an outie. So real quick, I'm just going to clarify this. If they gave me something like this, x squared minus 4 is greater than or equal to 0. I call this an outie. This is an outie. It's pointing outward from the problem. I could factor it and say x plus 2, x minus 2, greater than or equal to 0. Here's my number line. I'm going to knock this out quick. Here's -2, closed circle. Why is it closed? Because of this guy. Here's +2, closed circle. Why is it closed? Because of this guy. There's 1, 2, 3 regions. 1, 2, 3 regions. But you know what? It's an outie. This thing is an outie. So I'm going to just tell you, I could plug in a number over in this side. I could plug in -5. I could plug in 0. I could plug in regular 5. And what I'm going to find out is that my answer will be this. If you don't believe me, you can pick some numbers and plug them in for yourself. You will find any number that you pick that is less than -2 or greater than +2 is going to make this original problem valid or true, however you want to say that. Okay? That is how you solve a linear or a quadratic inequality. So let's just really quick look here. This guy is a double-sided linear. This guy is a quadratic, but I got to move the 12 over. And if I do believe that thing is going to be an outie. You can verify it for yourself. Okay, guys, that's that.